Hide that. Dang, got a good amount for a Friday. I'm impressed. I'm impressed. All right. All right. So if you guys weren't here on what's today? Friday. On Wednesday, make sure that you have watched the video for part 4.4. I know it was a little bit longer because we had a lot to go through that day. Plus, we get everything together. So all you had to do is copy the notes and the practice problems to get your free daily grade 100. Hopefully you turn that in. If you didn't turn that in, do it by midnight tonight. Okay. The new thing today is going to be pretty short. So what I want you guys to do is grab out your notes. I will be done by 10 o'clock. So pretty short lesson. I promise you'll be done by right around 10. Get your notes. This will be the first, what you should title it. There's not going to be a lot you're going to write down today. It's going to be very, very little. Then I'll show you your homework assignment, guys. So, and then you guys will be off to have a good weekend, right? What do you guys think about what happened the other day? Shouldn't have happened. Definitely shouldn't have happened. I went through all the emotions on this day. Anger, sadness. Well, you guys watch it at home? What was going on? Oh. Adriana says it was dumb. Yeah, very, very dumb. Dumb, crazy, like hypocritical. I don't know. I did love seeing a lot of the memes about it. There were some great memes that came out of that. But again, just super sad day for our country. Anyway, all right, you guys got the title? We'll get started. Every year when I do probability, I like to bring in some like games, especially card games, and I realize that there's a lot of people that don't know the basic things about cards. So I can't even give you like probability problems with like a deck of cards because we don't know how many cards are in a deck of cards. How many of you play card games? Like, how many of you are big on card games? No? Go fish. That's it? Nobody plays Speed. I used to play Speed a lot when I was a kid. We used to play a game called Egyptian. Yeah, love Speed, dude. Speed is the best. I guess, obviously times have changed. I was in high school 20 years ago. So, phones were not as prevalent, like especially smartphones. So, I mean, we always had a deck of cards. When there was downtime in class, we were playing cards all the time. Spades is my favorite. Yeah, Spades is a good game if you know how to play Spades. Nobody's brought that up yet. I'm surprised. That's good that you know how to play Spades, Adriana. First of all, so before I go to the first slide, how many cards are in a deck of cards? Do you know? 52 cards. Ray Lewis. Oh my God.
Well, he used to do, he would flip a card, and he always wears 50. He wore 52 because there was 52 cards in the deck.
How many suits are in a deck? How many different suits? Spoons is fun too. Oh, dude, I haven't played spoons in forever. Yeah, there's 4 suits. There's hearts, diamonds, spades, and clubs. So there are 13 cards in each suit. Obviously, you can see up here the different type of cards that are in a deck of cards. They go from ace all the way to 10, and then jacks, queens, and kings are your face cards. If I randomly select one of the cards out of a deck of cards, the probability of getting any one of these cards is 1 out of 52, right? 1 divided by 52, any one of these cards, because there's only one of each in a deck of cards. If I took that card and I put it off to the side, how many cards do I have left, Gustavo? 51. So now, what's the probability of me randomly selecting any one of these new cards? 1 out of 51, because there's only 51 cards left. My probability changes each time that I don't put a card back into the deck of cards, right? Okay, so we know that, and because of that probability, a lot of different games can be played with cards. How many of you want to go to a casino when you're of age and gamble. Play blackjack, play poker. I love playing poker. I'm a long-time poker player. You know how to play blackjack? No? Aiden, you know how to play blackjack?
No. Wait, is it 18?
21. 21. It's a variation of a game called 21. There are over 100 different variations of this game where you try to get a 21 blackjack, but you got to beat the dealer. Okay, the dealer blackjacks as well. Nobody wins. But there's obviously a lot of strategy that goes into blackjack too, especially knowing the fact that you can see all the cards of all the players that are playing. You can see that on the screen there. If there's 8 people playing and you know that there's what their cards are, that's going to go into your strategy on whether or not you want to get an extra card called a hit, where you get more cards to try to reach that 21. Because if you go over 21, you bust and you lose your money. Okay, so blackjack's a big game in poker. Like I said, it's fun play. What I really want to talk to you guys today about is roulette. What do you guys know about roulette? Anybody ever seen a roulette wheel? Aiden, what do you know about roulette?
Wheel and you put it. Because you drop a ball and whatever, if you gamble.
Did you see what Zuriel said?
I have no idea.
The Russian version be wild. Not Russian roulette, all right? Not Russian roulette. I'm not going to tell you what that is if you don't know it. If you don't know what that is, you can Google it. Actually, don't Google that. You might get some bad images in there. All right, don't Google that.
Really? You get bad images?
I wouldn't want to see what that is. Don't. Gustavo's over here laughing. All right. Not Russian roulette. Roulette is one of the most popular casino games. You go into a casino, have a roulette wheel. You can bet on any one of these numbers. So what happens in this wheel? The wheel spins. The dealer spins the wheel. They shoot a marble. It goes spinning around and around and around and around, and eventually it ends up in one of these little slots. Okay. What?
Is that Christopher Walken?
That's probably from Deer Hunter.
Yeah.
That's the most famous scene of Russian roulette ever. The little marble falls in one of these slots, right? There are 37 slots on them. You can win on 36 of them. All right? There's numbers 0 through 36. Let's say I want to bet on number 20. So I put my money on number 20. I put $100 on number 20 on this little board over here. They rig it. No, they don't rig it, actually. Let me tell you how they make their money. Every casino game makes their money. All right? I want to bet $100 on that it's going to land on 20. All right? I put $100 in chips on the 20. They roll the wheel. They roll it. The marble spins. If it lands on 20, guess how much they pay me? I bet $100. They're going to pay me $700. It's 1 to 7 payout if it lands on the number that you bet on. Okay? If it doesn't land on that number, guess who keeps the money? The casino does. But you have 10, 15 people playing all at the same time. So Zuriel, you could have a whole bunch of people put it on a bunch of different numbers. Somebody is eventually going to win, right? Those pay out a lot because it's not likely that you land on that number. It's only 1 out of 37. You can also bet on whether or not it falls on a red or a black number, or an even number or an odd number. Those only pay out 1 to 2. Meaning, if I bet $100 and I bet $100 on red and it lands on a red, I only get $200 back. Okay, so I get $100. I make $100. And almost half of them are red and almost half of them are black. So you almost have a 50-50 chance of getting on a red or black, of doubling up your money. However, it's not almost half because there's one green spot. I know it's hard for you guys here in class to see it. That you at home can see it clear as day on your screen. That 0 at the top is green. Who wins when the marble lands on green? The casino wins if the marble lands on green. You cannot bet on 0. You cannot bet on 0 over here. Casino wins. Everybody that bet on the table is just lost their money. Okay, so Zuriel, this is how the casinos keep their money, because guess what? The long-term expected value of these games is always going to be in favor of the house. So even though there are chances to win, and even though people do win lots and lots of money, over the long term, the casino is always going to come out ahead. Always. Unless you're a really crappy casino. Okay. Well, Trump Casino, I won't even talk about that. Never mind. Okay. So house is always gonna have an advantage. Here's what I want to show you guys, because I know at some point, you're gonna graduate and you're gonna turn 18, and you're gonna turn 21, and you want to do these things. What does everybody want to do when they get of age to do stuff? They always want to get a tattoo. They want to go to drink, and they want to go to a casino, right? These are some of the things that are going to happen. But I want to warn you about some of these things that you see when you walk into a casino. Because if you're going to go to a casino and you're going to go to a roulette table, you're going to see these screens right here. Okay, these screens are at every roulette table in every casino, and they're there because they show you the last 10 to 15 outcomes of every roll of the roulette wheel. Okay, so for example, this picture on the left, the red represents red, the white represents landing on black. Okay, that last time, usually at the top is the last one. So the last time this rolled, it was a red 27. The time before that was a black 29. The time before that was a black 17, and so on. So these screens show you what was going on. Let me ask you a question. See if you can answer this one, Aiden. If the wheel got 9 reds in a row, should you bet on black the next time? Why not?
I just walk away.
If you wanted to bet money, you're about to bet on a roulette roll. Okay, let's say you want to just bet it's going to land on red or black. It's either one. It's got to be one of the two, unless it lands on the green. If it got 9 reds in a row, is the probability that it's going to get black next higher than normal?
No.
Why not?
Well, because it hasn't hit black yet at all.
I know. So that's what I'm saying. So is the probability of getting a black next does it be like, okay, well, it's got 9 reds in a row, it's got to be black next? What do you guys think at home? Is the probability different? Is there a higher probability that the next one's got to be black? Why not, Zuriel? Unmute yourself. Say it out loud. What happens when they roll the marble and it lands on a number? What happens to that marble? What is that, gambler's fallacy or whatever? Yeah, good job. Somebody watched the video that I posted.
Oh yeah, I forgot about that.
Okay, does it matter? They're gonna roll the wheel. Marble's gonna land. They're gonna pick up that marble, and then they're gonna do what? Roll it again. Does whatever happened before dictate what's gonna happen next? No. Every wheel, every roll, every spin is independent of each other. Okay, they're all independent of each other. That is the gambler's fallacy. So why then do they even put these screens out there for people to see? If these rolls don't matter about what's going to happen next, why do they put them out? What's the point of the casino even putting them there? What do you think? To fool people. Yeah. They literally are trying to screw you. They're trying to screw you into betting a certain way, knowing that that's not necessarily going to happen. It could happen, but that's not necessarily going to happen. And they want you to increase your bets and increase the amount of money that you spend, thinking that you have a higher probability of getting that outcome. They're definitely trying to screw with you. So I'm telling you guys right now, the first time you go to a casino, go look at these boards. They don't mean anything. Okay? They don't mean anything. And you'll see people, I swear, just watch. Walk into a casino the first time you go to a roulette table. There's always people that are like, I see people with a notebook writing down like all like the last 50, 100, trying to analyze like what they should bet on next. It's all a waste of time. It's all a waste of time. Every individual spin is different. There's no possible way to predict what's going to happen in this game of roulette. So this is the first of 2 bullet points that I want you to write down. It's just independence. Go ahead and write this down real quick under 4.5. 2 events are independent if the outcome of one does not affect the outcome of the other. Okay. So obviously, one spin and roll in a roulette game does not affect the next spin or roll in the roulette game. 2 events are considered to be independent. After that, I will show you this proof. So write these. These are the only 2 bullet points that you'll write down. in probability, we can prove independence. We can prove that two things are independent if the probability of A, given that B has already happened, is equal to the probability of A. And again, this is a proof. I know you haven't done proofs since geometry, but I will prove this and I'll show you with two examples on the next two slides. So write these in your journal. Like I said, these are the only two notes today, and then we're going to do some very easy, quick practice problems, and then we'll be done. Give you about 90 more seconds. Let's see. All right. Does anybody at home need more time? Good. 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 All right. So before I do this with you guys, I'm just going to talk about basketball. I like to do sports statistics and sports probability because it's a lot relatable for a lot of people. I know some of you are not all into sports. Help me out real quick, Aiden. Do you know what a foul in basketball is?
Yeah.
What is a foul in basketball? Yeah, if I'm trying to shoot the ball in basketball and Aiden pushes me, bumps into me, slaps me on the wrist as I'm shooting while he's trying to block, that's a foul, right? Anytime that you make contact with me, that's a foul. So when I'm trying to shoot the ball, if somebody fouls me, is that going to affect me being able to make the shot? Sometimes, right?
I mean,
Unless you're Jordan. Yeah, right. Obviously, if somebody pushes me while I'm trying to make a basketball shot, I'm probably going to be less likely to make it than if I just were to shoot and nobody was around me. Okay? So I have this real quick practice problems. You don't need to write the problem. Don't even write the table. Just write number one and find the answer. Find the answer real quick for number one. It's an easy problem. Jacob kept track of the outcomes of his last 50 shots in basketball season, and here are the results. All right. Just write down number one. Find the probability that he made the shot. Okay. Find the probability that he made the shot. Write down the fraction. I'm going to call on somebody at home to see if they can give me the answer. We've already done this before. This is nothing new, guys. You should be able to be pretty easy for you. Carlos, once you think you come up with the answer, we put it in the chat for everybody to see. Just give me the fraction. The probability that he made the shot. You there, Carlos? Christiana, you there? Do you have the answer? Anybody at home can give me the answer? 16, almost. The total, how many times did he make a shot? Total. 19. So it should be 19 out of what? Out of 50. Yeah. Thanks, Carlos. Good job, guys. 19 out of 50. Again, on your homework, I want to keep asking you guys to write it as a decimal and percentage too, just because that's how you're going to see probability all three ways. You just need to make sure you get in the habit of knowing how to find it all three ways. Any questions on that? Should be pretty easy. Total times he made the shot out of the total. It doesn't have a condition on there, so we always use divide by the total if it's not a condition. All right, I want you to find number 2. You don't need to write down the problem. You don't need to write down anything else. Just write down the answer, so you have an answer. What's the probability that he made the shot given that he was fouled? Given that he was fouled. This time, we know we have a condition. I'm going to use this. We have a condition this time. The condition is that he was fouled. So we're only looking at the times that he was fouled. That's what that means. That's what this little symbol here means. See if that helps you answer this question now. What's the probability they made the shot given that he was fouled? See if you can write down the correct fraction. What do you think, Adriana? What's the probability that he made the shot given that he was fouled? Not 3 out of 19. Not 3 out of 19, because the condition is not making a shot. The condition is that he was fouled. So look at what I circled there. It's not going to be 3 out of 19. It's going to be 3 out of what? What do you think, Gustavo? 13. Good job. Yeah. It's going to be 3 out of 13. Okay. So remember the condition, and I'll do this again like we did the other day. Okay, just so you guys can see it. Remember, if there's a condition, that's my new denominator. That's what I divide by the total now. Okay. Hey, he's just trying to help out, Adriana. He's just trying to help out. All right. So before I put up this last question on this slide, help me out here. Look at this. What can we understand from this information? 38% of the time he makes a shot, but only 23% of the time he's making a shot when he got fouled. Is getting fouled affecting his ability to make the shot? Do you think that getting fouled affects his ability to make the shot? Yes or no? Simple yes or no. Yes, right? Obviously, getting fouled is affecting his ability to make the shot. How do we know that? How do we know that?
Because the percent is lower than.
Because the percentage is lower when he got fouled of making a shot than when it's just overall. Look, guys, the percentage dropped. The percentage dropped from 38 to 23% when he got fouled as compared to overall. But we can prove this because the probability of him making a shot was not equal to the probability of making a shot when he got fouled. If you go back and look at this notation here, I know that those two things are independent if they're equal to each other. If they're not equal to each other, they must be dependent on each other. Okay, they must be dependent on each other. Making a shot depends on whether he gets fouled or not. Okay, and we can prove that because the probability of it happening went down when I created that condition. You can see that it went down right there. Okay, does that make sense? And obviously, we relate that to real life. We know that getting fouled, getting pushed, or getting shoved, or making contact is going to affect your ability to shoot a ball inside a basket. Okay. So last slide I have for you. Last slide. I want you to try just exactly what we just did. There's 3 more questions. practice. Survey of 1,000 students was taken and whether they participate in after-school sports programs. And here's the results. So number 4, just write number 4 and write down the fraction. I want you guys to write down what's the probability that that somebody participates in after-school sports. I just abbreviated it real quick. So what's the probability that somebody participates in after-school sports? Find that probability real quick. And Adriana, if you want to redeem yourself, why don't you put it before anybody else? What's the overall probability? There's no condition this time. Oh my God. Yeah. Zuriel, Jared, you guys are right. And Adriana, all right, you're funny. You're right. 400 out of 1,000 is 40%. All right. 400 out of 1,000 is 40%. Who just got here? I don't know who that is. Okay. Next question. Okay. Just like the last one, I'm going to do, find this. What's the probability that somebody participates in sports given that they are male? Given that they are male. So this time, there's a condition. You're just looking at the males. You have an answer already?
Is it a 168?
Yes, this is 168. You're close, Zuriel, but don't forget, like what we did on the last example. The condition is that they have to be male. So we're only looking at the males now. Good job. Good correction, Zuriel. Good job, Carlos. 168 out of 420. Divide that in your calculator real quick. 168 divided by 420. What's the percentage for that? 0.4, which is also 40%. What happened this time is now the probability that's being male affects your participation in after-school sports programs? Are males participating in after-school sports programs at any higher rate than the overall or than females? Yes or no? No, they're not. We can prove that because, at least in this data, we can prove it because the probability of being a male participating in sports is no different than the overall probability of both males and females participating in sports. They were exactly the same. Because they were exactly the same when I found that probability, these two events, these two things must be independent of each other. Okay, being male has no say in the fact that you actually participate more in after-school sports than females. Okay, at least according to this data. And I think if we look at the overall trend, we see in real life that males and females don't necessarily participate in after-school sports, one more than the other. Okay, we have a lot of male and female sports on campus, right? So, this is your notes for today because it goes along with the last assignment, the last unit that we did the other day, or the last lesson that we did the other day. I'll show you what your homework assignment is, and if you guys want help, I can help you or go over it, but it's pretty straightforward. It's in there. It's called 4.5. It goes through this, but make sure that you read the directions before you start. You guys at home can either do this on a blank sheet of paper, your journal, take a picture, or you can actually do it in a Google Doc because all you're doing is writing the correct notation. You're going to write the answer as a fraction, a decimal, and a percentage. Make sure that you write the decimal to the nearest thousandth, which is 3 decimal places, and the percentage is to the nearest tenth, which is 1 decimal place. Basically what I've been doing for all these practice problems. So when you put these problems in your journal or on your paper, in your document or whatever, make sure that you're providing the correct notation. For example, on number 1, it says, what's the probability the student takes Spanish? Make sure that you're writing out like P Spanish and then finding the answer. Okay. And do the same thing for all the problems on this on this paper. So there's only 12 problems. And that's a good question, Adriana. I'll be putting in grades. The only 2 grades that will be put in before the progress report will be 4.2 and 4.3. 4.4 and this one will be put in after the progress report, but before the report card. Okay. Hold on a second.